Hello everyone, welcome back to today's session. Myself, I am Santosh, working as a lecturer in Electronics and Communication Engineering Department, Government Polytechnic Karkala. So in the last class, we have discussed load store instructions. What are the different types of load store instructions? The various load store single register transfer instruction. Actually, there are three types of load store instruction: single register transfer, multi-register transfer, and swap instruction. So in that last class, we have discussed single register transfer instructions, and also we have discussed the different addressing modes related to single register load store instructions. So in this session, I am going to explain multiple register load store instruction and also the addressing mode for multiple register load store instruction. So for each instruction, I will give an example at the end. So again, you will be having multiple choice questions. So I have already explained single register load store instructions in the previous session. So we have already studied how to load one register with some data from the memory. So this data transfer is basically 32-bit, that is the word only. So at a time you can load or store 32-bit of data, that is one register data. But if you want to load multiple register data, so inside the memory, or if you want to access multiple memory location, then this is possible with the help of multiple register load store instructions. So load store multiple instruction can transfer multiple register between memory and the processor in a single instruction. So we can write only single instruction that can be able to transfer multiple register between the memory and the processor. The transfer occurs from base register Rn pointing into the memory. So here we are using one register acting as the pointer that holds the starting address of the memory. So compared to single register transfer instructions, multiple register transfer instructions are more efficient for moving block of data around the memory. So this is the syntax of LDM and STM. So in multiple register transfer, so we have only two instructions, LDM and STM. So what is LDM? So LDM means load multiple, ST means store multiple. So load multiple register, STM means store multiple register. So load means so as we studied last class, so load means memory to register. So here also direction is same. So it's loading the data from memory to register, but multiple register. It will copy into multiple register. Whereas in store, the direction is from register to memory location. So here also multiple register data transfer to memory location. So this is the condition. So this is the optional. So LDM and STM instruction is also conditionally executed. Then addressing mode, so we have different addressing mode supporting to multiple register transfer also. I will explain it in the next slide. Then Rn, so Rn is it is used to hold the starting address of the memory, and these are the register set. So here we can use n number of register in the list. So where n is the number of register in the list, Rn determines the source or destination address. See, during the load operation, so data is transferred from memory to register. So now the memory is the source and registers are the destination. So here Rn holds the source address. During this STM store multiple operation, so direction from register to memory. So now the memory is the destination. So it is used to hold the destination address. So in these registers, so we may listed in any order. So we have R0 to R15, total 16 register available in the ARM controller. So we can use any of the register, and we can also listed in any order, but the data is always loaded in order with the lowest number register getting the value from the lowest memory address. So this is the addressing mode, different addressing mode supporting for the load, store, multiple instructions. So here we have 4 addressing mode: IA, IB, DA and DB. So what is IA? So IA means increment after. So increment after. IB means increment before. DA means decrement after. DB means decrement before. See here, so we are moving multiple registers, multiple word from register to memory or memory to register. So here we are specifying only the starting address of the memory. So after each load or store, the memory address will be automatically incremented. So how to increment that memory address? That is indicated by the addressing mode. So if we specify IA, so increment address by 4, so this will increment address by 4 after each load or store. So first it performs load operation, then it will increment the address by 4. So first load, store, then it is increment by 4. So whereas in IB, increment address by 4 before each load and store. So here it perform increment the address by 4, then it perform load or store operation. Whereas in DA, it decrement address by 4 after each load and store. So here also it perform first load or store operation, then it decrement the memory address by 4. So whereas in DB, decrement address by 4 before each load or store. So decrement address by 4 before. So first it will decrement the address by 4, later it performs load or store operation. So this is the starting address and this is the ending address. So in case of IA, so what is it? Performs increment address by 4 after each load or store. So it perform load or store operation. So the beginning address is Rn itself. So Rn hold the starting address. So the beginning address is Rn itself. After the load, this register is added by 4. So Rn plus 4. So that is the address for the next word. Again loading or storing the second word, again it will increment by 4, Rn plus 8. So similarly it will go on. So this is the end address. So similarly in IB, so increment address by 4 before each load or store. So here it increment the address by 4 first, then it perform load or store operation. So starting address, the base address is held in Rn, but so before load it will increment by 4. So Rn plus 4, from this memory location either load or store operation will be performed. So this is the ending address. So similarly in DA, this is the starting address, this is the end address. For DB, this is the starting address, this is the end address. So this last column represent the write back. So this exclamation symbol is present, Rn is updated with the ending address at the end of the instruction. If exclamation symbol is not present, the value of Rn will be unchanged at the end of the instruction. So I am directly taking an example. So first example, consider LDMIA. So load multiple register, addressing mode is IA. So increment after. So increment address by 4 after each load. Means it perform first load, then it increment the address by 4. So we can write this instruction like this also. So LDMIA R0, R1, R2, R3. So here we have used dash. So the dash symbol indicates the range. So whenever we are using the register in sequential order, R1 to R6 or R1 to R8. So we don't need to write R1, R2, R3, R4, R5, R6. If it is in the sequential order, so we can write like this also, R1 to R6. So it will take 6 register, R1 to R6, or you can specify individual register like this also, R1, R2, R3, R4, R5, R6. So here I am taking only 3 register, R1 to R3. So let us consider before execution the memory address contains so these data. The memory, the starting address memory. So 8001C contains 4, 80018 contains 3, 80014 contains 02, and 80010 contains 1. And register initially assume that 00. Initially it is 0. The starting address held by R0, that is pointed to memory location 80010. See here. So 80010. So this is the starting address. So initially all register values are 0, and these are the initial values of the memory location. So here I am using word alignment. So yesterday I said, so in the last session I told, so each irrespective of the memory size, so each memory location we can store 1 byte only. So don't confuse here, we have saved 4 bytes. So here 80010, so next location is 80014. So 80010, 11, 12, 13. So 4 location. So this data will be stored. So later 14, 15, 16, 17. So there this data is stored. So 18, 19, 1A, 1B. So 4 byte data stored here. Then next address is 1C. So 1C, 1D, 1E, 1F. So 4 bytes. The next location is 20. So 20, 21, 22, 23. So like this. So I am not sequentially, it is not mentioned here. So it is address is increment by 4, because here each memory location contains 4 bytes. So 10, 11, 12, 13. So next one is the 80014, 15, 16, 17. Then next location is 18, 19, 1A, 1B. So and so on. So after execution of LDMIA, see, so load multiple register, increment address by 4 after each load. So first it will perform load operation, then increment address by 4. So now that R0 is pointing to 80010. So in that memory location the data is 1. So this data is loaded to R1 register. So after execution, the first data, the first word is loaded to R1 register. So after load, the memory address is increment by 4. So R0 plus 4. So R0 contains 80010 plus 4 means 80014. So in that memory location the data was 2. So this data is moved to R2. See here. So before R1, R2, R3 are 0, 0, 0. So now you are getting the data from memory location. So again still it is not ended. So still one more register is there in the instruction. So R0 again is the increment by 4. So R0 plus 8. So now the memory location is 80018. So in that memory location data 3 is present. So this 3 is loaded to R3 register. So that is the end of the LDM instruction. So here we have used explanation symbol in the instruction. So the R0 is updated. So is now the symbol is present. So Rn is updated with the ending address. So now the ending address is 8001C. So after load what will happen? It will increment by 4. So R0 plus 12. So 80018 plus 4 means 8001C. Now that is the ending address. So this address is updated to R0 register because explanation symbol is present. If this symbol is not present, then R0 is unchanged. Mean so R0 will contain only 80010. So I have mentioned in the previous slide, I have mentioned the starting address, end address formula. So for this example, the starting address is Rn. So Rn is the base register, that is the R0. So starting address is, that is the content of R0. So 0008010. So here, so this is the starting memory address. The end address, so here n is 3, so we have mentioned R1 to R3, there are 3 registers, so n is equal to 3, so Rn plus 4 into n minus 4, so Rn, that is the R0, so that contains value 80010, 4 into 3, n is equal to 3 minus 4, so 80010, so 4 into 3 means 12, so that is the decimal value, so in hexadecimal it is C, so minus 4, so you will get answer 80018, see here 80018, so we are loading 3 words from the memory, so this is the starting address of the memory and this is the ending address of the memories. From these 3 memory location, data is loaded to R1, R2 and R3. So here we have used Rn, so Rn exclamation symbol, so Rn is updated with the end address after execution of this instruction. So the formula is Rn plus 4 into n, so Rn 80010 plus 4 into 3, 12, so 80010 plus C, so that is equal to 8001C. So this is the end address, updated address. So similarly consider LDM IB. So load multiple register, the addressing mode is increment before. So increment before. So increment address by 4 before the load operation. The first step is the increment address by 4, then load. So these are the initial values. I have taken same values. So now the address is, the starting address is 80010. So 80010. So now R0 is pointing here. So increment address by 4 before load. So first it will increment by 4. So 80010. So it is increment by 4. So the address is now 80014. So that is the first starting address of the memory. From that memory location, the data is moved to R1. So now 0002 is moved to R1 register. So again, still 2 registers are there. So again R0 is increment by 4. The now memory address is 80018. So in that memory location 3 is present. This data is moved to R2. So R2 contains 3. So still one more register is there. So again it is incremented by 4. So increment before the load. So first it will increment by 4. So now the address is 8001C. In that memory location is 4. That data is moved to R3. So that is the end of the instruction. So again here we have mentioned exclamation symbol, so it will update the end address to R0. So now the R0 contains 8001C. If symbol is not present, then R0 value will be unchanged, that is 80010 if this symbol is not there. So next consider LDM DA. So I have taken same initial values before execution, but the starting address decrement address by 4 after each load. For this case we need to give higher address because the address is decrement by 4. So we should move from higher address towards lower address. So we should give here higher address. So here the starting address is 8001C. So decrement address by 4 after each load. So decrement address by 4 after each load. So first it will decrement address by 4 after each load. So after each load, first it will perform the load operation, then it will decrement by 4. So here it is pointing here to 8001C. So first it will perform the load operation. So from that memory location data is moved to R3, so not R1. So here it is moving to R3 first, then it is decrement by 4. Now the memory location is 80018. So in that memory location 3 is present, so this 3 is moved to R2 register. Again it is decrement by 4. So now the address is 80014. In that memory location 2 is present, this 2 is moved to R1 register. So decrement address by 4 after each load. So after load again it will decrement by 4. So now the end address is 0x80010. So here there is a one question: why at this particular location R3 is loaded, why not R1? See in the previous example, see here, yes, here, so here it is, first it is loaded by R1 register, then R2 register, then R3 register. But in this case here R3 is loaded first, then R2, then R1. So why it is? This is simple to answer to this question. So whenever we put data inside this memory using multiple load store instruction, please remember these things. At the lowest address always lower register is loaded, and at the highest address always highest register is loaded. So in the previous slide I have mentioned here. So the register, so the register may be listed in any order, but the register are always loaded in order with the lowest number register getting the value from lowest memory address. So here, see here, so 80010 is the lowest address and 8001C is the highest address, right? The starting address is, so this is 8001C. So this is highest address, so the data is moved to highest number register, and this is the lowest address 80014. So this value is loaded into lower register, so that is the R1. So that is the difference. So we are moving from higher address to lower address, so it is loaded with highest register first, then lowest register last. In case of IA, so we are moving from lowest address to higher address, towards higher address. So there the lowest address data is moved to lowest register and highest address data is moved to highest register. So next, LDM DB. So here load multiple register, decrement before load. So decrement before. So here, so it will decrement by 4. First operation decrement by 4, then it will load. So consider these are the initial values. So this is the starting address. So R0 contains 8001C. So here it is pointing. So that is the beginning address. So DB means decrement address by 4 before load. So first it will decrement by 4, then load. So this is the address 8000800018. From that memory location it's loaded to R3. Again highest address, highest number register. Again it decrement by 4. So now address is 80014. In that memory location 2 is present. This data is moved to R2. Again it is decrement by 4, 80010, then it is loaded to R1. So highest addressed memory to highest number register, lowest address to lowest number register. See here R0, that is the end address updated to R0, so 80010. So see the difference. So now take store operation. So till now we have discussed load. Load means memory to register. Store means register to memory. So multiple register. So this is the initial value. So now assume that all memory location contains 0000. So in previous case I have taken register initial values of the register are 000. So here the memory location values are 000. So the starting address is 80010 that held by R0, and the register values R1 to R3 contains R1 contains 1, R2 contains 2, R3 contains 3. So same addressing mode IA. So store means register to memory, increment address by 4 after store. So here it will store first, then increment address by 4. So this is the starting address 80010. To this memory location R1 data will move. So R1 contains 1, so that data will move to 80010. So after this address is increment by 4, so now the address is 80014, there R2 register value is moved. Then again address is increment by 4, so 80018 memory location, there R3 register value is moved. So here 3 register values are loaded to memory location. So after load, what will happen? Again it will increment by 4, but it won't store any value from register. Already 3 register data already stored. So this is the ending address. This address will be updated to R0 because of the exclamation symbol. So similarly STM IB. So store multiple register, increment address by 4 before store. So before store. So here it increment the address by 4 first, then store. So these are the initial values. So now the starting address is 80010. Now the R0 is pointing here. So IB means increment the address by 4 before STM store. So first it will increment the address by 4. So 80010 becomes 80014. So in that memory location R1 value will be loaded. So after that it will again increment by 4. Now the address is 80018. There next register R2 value will be moved. Then again it will increment by 4. So 8001C, there R1 value will be moved. So increment address by 4 before. So 3 times it is loaded the value and 3 times it is incremented by 4. So now the R0 is updated with 8001C. That is the end address. So okay, for this example also I will calculate the starting address, end address. So for this STM IB, the starting address is Rn plus 4. Rn plus 4. So where Rn, that is nothing but R0. So R0 content is 80010 plus 4. So 80014. See here 80014. So that is the starting address of the memory. So that is, see, the R1 value is moved to this memory location, starting memory location. It won't move to 80010 because increment address by 4 before store. So before store it is incremented by 4. So now this is the starting address of the memory. So end address is equal to Rn plus 4 into n. So where n is equal to 3 because here we have used 3 register R1 to R3. So Rn contains 80010 plus 4 into 3. So that is the 12 means C. So 80010 plus C. So 8001C. So now this is the end address. So 80014, 8018, 80001C. So 3 memory locations for 3 word. Starting address, end address. So Rn, the right back. So Rn equal Rn plus 4 into n. So Rn contains 80010, 4 into 3, 12. So 80010C. That is the end address updated to R0. If exclamation symbol is not present, the value of Rn will be unchanged. That is R0 is equal to 80010 if this symbol is not present in the instruction. So I have taken only the two example for the store instruction. So try for these two instruction, STMDA and STMDB. So similar to LDMDA and LDMDB. So what is mean by STMDA? So store, DA means decrement address by 4 after store. So STMDB means decrement address by 4 before store. So that is the difference. So you try these two. So at the end of this session, so today we have studied, analyze and understand the multiple register transfers. Last class we have studied single register transfer. So today we have studied multiple register transfer. And also we have studied addressing mode for the load store multiple instructions. So again, take a pen and paper. So let's have a multiple choice question now. So again, you just write the question number and write the options, which is the right answer for this question. Write the option. At the end, you can assessment by yourself. The first question is dash symbol is used to signify write back mode. So option A is hash symbol, option B that cap XOR, C ampersand, and D exclamation symbol. So which symbol is used to signify write back mode? The answer is yes, D, exclamation symbol. So we have used in single register transfer also we have used, and also multiple register transfer also we have used this symbol. So next question is the instruction which are used to load or store multiple operands are called dash. The instruction which are used to load or store multiple operands are called dash. So A, banked instructions, B, lump transfer instruction, C, block transfer instruction, D, DMA instruction. The answer is block transfer instruction, C. So here we are moving block of data. Multiple means some block of data from memory to register or register to memory, not single value. So we are moving block. So this is called block transfer instructions. So next question, the instruction LDM R10 comma within the square bracket, within the flower bracket R0 comma R1 comma R6 comma R7 is dash. So option A loads the memory content pointed by R10 into R0, R1, R6 and R7 register. B, creates a copy of the contents of R10 in the other register except for the above mentioned ones. C, loads the content of the register R1, R0, R6 and R7 to R10 register. D, writes the content of R10 into the above mentioned register and clears R10. The instruction LDM R10 comma R1 comma R0 comma R1 comma R6 comma R7. The answer is A. So load means memory to register. The memory's address is pointed by R10 register. So R10 is the base register. The address is pointed by R10 register. So loads the memory content, right, pointed by R10 into so R0, R1, R6 and R7 register. So memory to register, that address is held by R10. So A is the right answer. See fourth, next question. So addressing mode DB for load store multiple instruction indicates a decrement address by 4 before each load or store, decrement address by 4 after each load or store, increment address by 4 before each load or store, increment address by 4 after each load or store. The addressing mode DB. So DB means, yes, decrement address before by 4 before. So D means decrement address, B means before. So decrement address by 4 before each load or store. So A is the right answer. So next question. Load store multiple instruction can transfer multiple register between memory and the processor in a dash instruction. So A double, B single, C both A and B, D none of the above. So load store multiple instruction can transfer multiple register between memory and the processor in a dash instruction. So answer is single. So single instruction. So as I told, that is the advantage of ARM controller. So we can transfer multiple register R0 to R10 or R0 to R6, any number of register, so using single instruction. So B is the right answer. So next question is, general purpose register holds the dash address A, B data, C both, D none of the above. The general purpose register available in the ARM controller holds the, whether it holds address, data or both or none of the above. So answer is both. So the general purpose register is used to hold data as well as the address. So I think you have observed in the STR and LDR instruction, also in STM and LDM instruction. The one of the register hold the address and some register hold the data. So next question. LDM stands for dash. A load register, B load single register, C load multiple register, D all of the above. LDM stands for load multiple register. So C is the right answer, load multiple register. So next question is, LDM IA R0 with explanation symbol, comma, R1 to R3, which is equivalent to A LDM IA R0, comma, R1, comma, R1, comma, R3, LDM IA R0, comma, with flower bracket R1, comma, R2, comma, R3, C LDM IA R0, comma, with flower bracket R3, comma, R2, comma, R3, D all of the above. So the answer is B. So here, so as I told, dash symbol, it is used to mention the range. So whenever we using the register in sequential order, so we can use like this. Instead of writing R1, comma, R2, comma, R3, we can mention R1 to R3. So B is the right answer. So next question is, in IB addressing mode, the starting memory address is dash. So A Rn, B Rn plus 4, C Rn minus 4 into n, D Rn minus 4 into n plus 4. In IB addressing mode. So answer is Rn plus 4. So what is IB? Increment address by 4. I means increment address by 4. B means before load or store. Means first it will increment the address by 4, then load or store. So our beginning address is, the starting address is, before only it will increment the address by 4. So Rn, the base register plus base register value plus 4. So Rn plus 4. The last question is, STM stands for dash. A store register, B store multiple register, C store single register, D none of the above. STM stands for store multiple register. So B. So store multiple register. So assessment by yourself. So calculate how many questions you have correctly answered out of 10. So okay, I will end today's session. So today we have learned data transfer of the multiple register LDM and STM instruction, and also we have studied the different addressing mode supporting to LDM and STM instruction. In the next session, so we are going to learn swap instruction. So there is one more instruction, swap instruction, and also the stack instructions using LDM and STM instruction. So we will discuss it in next session. So thank you.